that topic, you should be able to cross-check with it on the Facebook page of Top Television. It was already posted there, and also on the website of Cord High School. So yesterday on Monday, I had left you with some work. If you can show me that example 2, I mean slide 2. I left you with some work, and yes, there it is. I left you with some work, and you're supposed to work it out. I had done for you only example Roman numeral 1, and I told you to try out 2, 3, 4, 5, and 6. Like I told you, you need a calculator. That's why I've tried to put it there in the background so that you can be able to use it. So a calculator, when you have that calculator, this is a new topic to us. There are several buttons in there, and as you can see, when you check just below, if you can make the calculator a little bigger, make the calculator a little bigger so that my guys can see it. So when the calculator is coming, so when you look at that calculator critically, there are several buttons there. There is a button for cosine. There is a button for sine, and there is a button for tan, that is tangent, sine, cosine, and tangent. So if you're asked to get, for instance, the sine, if they want you to get the sine of 30 degrees, oh yes, you can see them now, where you see the red buttons there, DEL and SC. So the buttons I'm talking about are sine, SIN, and then the cos button, and then the tan button. So if you want to get the sine, say, of 20 degrees, you'll write that button, SIN, and then 20, and then you press the equal sign at the very bottom of the calculator. If you want to get the cosine of, say, 20 degrees, you'll do the same thing. You'll press the cosine button, cos, then 20, and then you press the equal sign. And so is the one for tan. So we can go back. So going back to our example, slide 2, where they were asking us to get the sine of, say, 30 degrees. Sine of 30 degrees. So you'll go to your calculator, press the SIN of 30 degrees, and it will give you something like 0.5. And then the cosine, because they had asked us to get all these values, when you press on your calculator, you're able to get something like 0.86 and then 6. And then the tan of 30 degrees, when you press the tan of 30 degrees, you'll be able to get something like 0.57 and then 7. So I'm not going to continue with those. You can proceed with 3, 4. I've put there the answers. You can be able to cross-check and see. So let's go to our next slide. Yes, I left you with that also on Monday, and I'd asked you to get the tan, the tangent, the sine, and cosine of the marked angle. And of course, as you can see from there, we had learned the other day on Monday that the tan of an angle, or a triangle, sorry, the tan of an angle in a triangle is given as, if you could remind me, let's look at the blackboard now. The tan of, say, this angle theta. Let's have it on the blackboard. The tan of theta will be the opposite over the adjacent. Yes, that's what you remember, the soccer tour. I gave you that memory aid. So the tangent of this angle will be the opposite over the adjacent. So it will be 20 out of 25. If you so wish, you can reduce that by crossing here by 5, that's a 4, by 5 here, that is a 5. Or you could even punch that in your calculator and should be able to produce for you a value such as 0.8. So that is the tan. So but of course they asked us to get the tan, the sine, and then the cosine. Now we know that the sine of an angle is, remember yesterday again, going back to our soccer tour, is the opposite over the hypotenuse. What is our opposite here? If this is theta, my opposite is here. This is a right angle. Opposite is 20. So this is 20 over the hypotenuse. We had said the hypotenuse is the longest side. The hypotenuse is the longest side. But now, as you can see here, it's not given. But remember, this is a right-angled triangle. So I can make use of Pythagoras theorem to enable me get the hypotenuse. And of course, from Pythagoras theorem, if I can work it out here for you, the hypotenuse squared should be equal to 20 squared plus 25 squared. So this is 400 plus 625, and this is 1025. So this is my hypotenuse squared. So then you get hold of your calculator. Get hold of your calculator. I'm also getting mine. Okay. I'm getting mine. Let me put it in my calculator and see what gives me the square root of 1025. What am I getting? Something like 32. H will become 32.0156. So I'll put this here. 32 point, but yeah, we can do that. Okay, let's do that. 0156, and then you can divide that and then get an answer for this. But you could even have done it better. Instead of us wasting time to calculate this already, you could just put a square root here. So you would say your h is the square root of 1025, so that instead of putting there that value with the decimals, we instead replace it with this and then punch it in our calculator. So if I used that, let me see what I would get. The root of, I'm using my calculator also, divide by the root of 1025. Yeah, something like 0.7904. So that's the value of the cosine. So you can also get the value of the sine. You can also get the value of the cosine by saying it is adjacent over the hypotenuse. Okay, adjacent over the hypotenuse. So let's go to the next slide. The next slide, like we've been doing it before, we've been telling you to keep visiting that site called high school. It has a lot of work for you. If you're still at home and you have no learning materials, don't sit at home without learning materials. Visit that site. It has rich content in all the subjects. A lot of work has been posted there for you to help you during this time. But you'll not just be able to go there and immediately get the work. You have to sign up for an account. You have to get registered on the site, to be able to access it. Let's just go to the next page and I show them how it looks like. Yes, so when you put in that www.codehighschool.ac, that's how it will look like. So you have to tap on that icon for join e-learning and then register some form there, and you press on complete setup to help our online administrator to see your account request and activate it. Alternatively, On the blue bar at the extreme end, you're seeing the word sign up. You tap there, fill in your details, and complete the setup. By pressing complete setup, our online administrator will be able to pick up your account request and authorize it. After it has been authorized, that's when you can now come back and log in. You press login and use your username and password. If you find that the system is still rejecting you, it simply means that your account has not yet been approved, so you exercise some patience. You come back again later. Okay? Good. Now, our discussion today, if you could take me to the next item. Our discussion today is about solving a right-angled triangle. So, solving a right-angled triangle and our objectives. In other words, at the end of this lesson, what do I expect you to know? One, part A is clearly written there for you, and part B is there, and then part C is there. So those are our three key learning objectives. And it aids us to help us understand that better. I'm going to give you an example. To start by giving you an example. First of all, what is to solve a triangle? To solve a triangle, you can get me back the blackboard. Solve a triangle. Solve a triangle is to find all its sides and angles, the missing sides and angles. Look at this triangle, for instance. If, for instance, I gave you that triangle and I labeled this as maybe 30 degrees, and I said this is maybe 6 centimeters, and then I've not given you this, I've not given you that, I have not given you that, of course this is 90 degrees. So to solve a triangle is to ask you to help us get these missing values, these ones. So if you can get this, then get this, and even get this, then you will have solved that triangle. And trigonometry is going to help us learn how you can get all these missing sides. Okay? Because when we had studied the construction, you could use construction and then measure all of this. But now with trigonometry, you don't even need to do the measuring. We can be able to establish these lengths without doing the actual construction. So let's look at that example one on the next slide so that we understand this better. Good. So look at that example on your screen. Part 1 especially. We've been given a right-angled triangle. We've been given a right-angled triangle, ABC. So one of the angles there is 20 degrees. One of the angles there is 20 degrees. And then we also have, that is 4. It's one of the values. And then there is a question mark, just the way you're seeing it on the screen there. The way you're seeing it on the screen there. So you have the 20 degrees, you have the question mark there, so that's a missing angle I'm talking about. That is the missing angle. And then we also have the 4 centimeters. So the question is, solve the triangle. Solve the triangle. Like I've told you, solve a triangle is about finding all the missing lengths and the missing angles. So the question is, how do you obtain those question marks? How do you obtain the line AC? How do you obtain the line BC? And how do you obtain the line AB? Okay? If you can be able to do that, then you would have solved the triangle. And from our discussion yesterday, can you try and start working it out? Let me give you like a minute. You try to work it out, and I say, yeah, that's Roman numeral 1. Try it out. Try it out. Try it out. You're forgetting. Please. We learned this yesterday. We learned this yesterday, remember? Yeah, try it out. Try it out. Okay, then let's first let's get back the blackboard and we see. So I have my SC. They're asking me to get SC. To get my SC, this is my this is angle 20. Now, if this is 20, then what is this? What is that side? You remember in Monday we discovered how to name the triangle. We talked about the opposite, the hypotenuse, and the adjacent. So what is this side? Oh, the hypotenuse. Yeah, we agreed that always the longest side is the hypotenuse. But there was a controversy on these two. Which is which? Which is the hypotenuse? Which one is the adjacent? But of course, we resolved that by saying that usually where the angle is resting, now like here, the angle is resting here. The shortest length, the shortest side where the angle is resting is normally the adjacent, and this becomes the opposite because as you can see, this angle is facing that side. So this is my opposite for this angle, and this is my adjacent. You remember the soccer tower? We talked about this as a memory aid. Okay, so I have the angle, I have the adjacent, I have the opposite. So let's check it out. Can I use sine? So you try to identify these. Can I use sine to help me get one of these? Let me see. Can I use sine here? I have the opposite. Hypotenuse is not known. Oh, yeah. It's not known. The adjacent is not known. Hypotenuse is not known. Opposite is known. Adjacent is not known. So to begin with, by doing that simple elimination technique, I cannot start this problem by trying to apply the cosine ratio. It will not work because all the things are unknown. However, I can start by saying that the sine of 20 degrees will be the opposite over the hypotenuse. And what is my opposite? My opposite is 4 over, what is my hypotenuse? Hypotenuse is AB. Then I do the cross multiplication. Okay, so when I cross multiply my AB, it will be, just look, cross multiply. So this is going to be this times this. So I'm having AB times the sine of 20 degrees is equal to 4. But remember the question is, no, I need the AB. So I'm going to divide both sides by sine 20, divide both sides by sine 20. So this can cancel with that. So then I end up with my AB is equal to 4 out of the sine of 20 degrees. And remember, getting back to our calculator, we had said the sine of 20, already shown you the buttons where they are. Now I'm also going to use mine. I'm going to press mine. say what is the sine? I will say 4 divided by my sine 20. What is that value? I am ending up with 11.695. They did not give us units, so we shall also leave it at that. My AB is that. Remember, we are solving the triangle. And we said solve the triangle, it's about finding all the missing lengths and sides. So we've discovered this. But for this, not yet. For this, not yet. So how do we get this one? Now we know the hypotenuse. By the way, I can even use the cosine. But let's try it. Let's use that already. Because at least we had already identified earlier that it was only missing the adjacent. So I will again say that the tan of 20 is the opposite over the adjacent. And what is my opposite? It is 4. What is the adjacent? It is SC. So this is 4 over SC. This is tan 20. And we do the same thing, cross multiply. And when you cross multiply, you'll end up again with SC is 4 out of tan of 20. Let me check that out. 4 divided by the tan of 20. That's roughly 10. So quickly, when you work that out, try to make it the subject. I will not do that for you. It will be 10.8. No, 10.98 or 99. 10.99. That becomes my AC. We are solving the triangle. And we said solve the triangle, it's about finding all the missing lengths and sides. So I've already got this. I already have this. I have this angle. This right angle is also known. Oh, this angle is missing. I work it out using a simple principle. And the principle is the angle sum of the interior angle sum of a triangle is 180. Good. 180 degrees. So add these up and equate to 180. I'm not going to do that for you, but check that angle B will reduce to 70 degrees. Angle B will be 70 degrees. You have solved that one. If I can get back that example, once more. That example, if I can have it once more, I hope you've copied this. So there we are. So that is Roman numeral 2. You have that angle, 30 degrees, then the 7. So they want us to get A and C. This is more or less like the number we've just been doing. And I'm not going to do it for you. I will need you to try it out. You can see that if now I have sine, which side is opposite 30 degrees? Which side is that? 7, correct. And the adjacent is therefore A. The hypotenuse is C. So juggle through those ratios. Sine, sometimes you may have to use a sine or a cosine or an adjacent, a tan, I don't know. But try that out. So let's look at the next slide. That's 8. There's an interesting example I want you to see here. How powerful trigonometry is. And that's how it is really. It can help us estimate things we cannot be able to read. Like now you see there, that tree. It is too tall. You may not be able to measure it accurately, yet you're interested in knowing how high it is. Trigonometry can help us be able to estimate such heights. Even tall mountains like the Himalayas ranges in India, Mount Everest. Trigonometry are some of the skills used by surveyors to be able to estimate the heights of such mountains. They don't move there. They don't move from there up to the top trying to measure something. They just use trigonometry. How high is it above the sea level? And then they're able to use trigonometry to estimate how high such high-rise landforms are. So here's a simple example for us that to find the height of a tree, a person walks to a point 30 feet from the base. The base is like where the tree stump is set, the foot. Sometimes you call it the foot of the tree, from the foot, okay, and the ground. She measures, this was a girl, she measures an angle of 57 degrees between a line of sight to the top and the ground as shown in the figure. Okay, then the question is, how high is the tree? How high is the tree? But for instance, if you connected a string from the tip of the tree up to the ground, the angle it will be making will be 57 degrees. And now the question is, how high is that tree? So this reduces to a right-angled triangle problem. Right-angled triangle problem. So we model a tree. When I say model, it's like to represent a tree with a straight line. So look at what I'm having here on the blackboard. This is 57 degrees and this is 30. So we look at, we model, I've modeled now my tree as just a mere line. You see? Mere line. Okay? So how high is the tree? Very simple now. Look at, very simple. I think you can even complete this. How high is the tree? This is angle 57. How high is the tree? The tree is it's what? The opposite. Good. The tree is the opposite. And this is, oh yeah, the adjacent. I thought you were going to say hypotenuse. Hypotenuse, we agreed that that one has no question. The longest side is always the hypotenuse. So, going back to our soccer tower, I told you, never forget this. It's a very powerful tool that will keep helping you not forget that those three basic principles. So, I have the adjacent. So because I don't have the opposite and the hypotenuse, don't think about trying to use the sine ratio here. It will not work. How about the cosine? Can we use cosine? Now cosine, the adjacent is there. The hypotenuse is not there. So, and yet we don't need the hypotenuse. So cosine is already ruled out. Let's check out tan. Tan. I have the angle, I have the, of course here also I have the angles, I have the adjacent, I don't have the opposite. But remember, what I don't have is what I'm looking for. So this is a good one. It's a good one for us to say that the tan of 57 is the opposite over the adjacent. And so this is the tan of 57 degrees is the opposite, which is h out of 30 degrees. So you can then do the cross multiplication. So that my h is 30 tan of 57 degrees. So I can get back to my calculator, press the tan of 57. What is my tan of 57? You see, even me, I'm using the calculator. Are you seeing that? So even you should also be using a calculator. Those values are found on the calculator. So tan 57, what value is that? So this is 30 times 1.5398. So we round off to 4. So this should be 40. Okay? Then I multiply that by 30 times times 30 it is 30 times 1.540. What do I get? 46.2. So this is 46.2. These are feet. How high? You can focus it so that my friends can see it. So how high? That's 46.2 feet. That is how high the tree is. So you don't need to climb the tree with a string to see how high it is. So let's look at the next example. That is slide 9. The next example, this one I'm going to leave it with you. So the moment you see it there, try to write it. So it's still about trigonometry. It's asking us a simple, the example is coming. It's coming. It is coming, the example. So example, slide 9, yeah. So it's a simple problem there. It's a simple problem there for you, and they're asking you to get the value of x. Capture the value of x in the figure below. Now you can see the height is 82. So those are two triangles in one. They have brought them together to share the same height. So what you're going to do, you're going to isolate the smaller triangle, which has angle 63, and get its adjacent. And also isolate the other triangle, the big triangle, which also has the height 82 and the angle 39, and get its adjacent. Now, because when you add up the adjacents of both of those triangles, you get the x. You would have obtained that. So get the adjacent of the smaller triangle, and then so the adjacent of the bigger triangle, add them up, that will be your x. That's good for you. Okay, now let's go to the next slide. That's slide 10. We want to talk about finding angles when you've been given just sides. And that's what I was able to write up there for you. That to be able to obtain an angle from the sides of a triangle, we need to get the inverse of the trigonometric function, or ratio for that matter. And for instance, I was trying to show you there an example. You have that right angled triangle XYZ, and they have given that as the 15, and 5, and then the other one 12, and they want us to get angle Z. Of course, we know angle Z, the opposite, I can see it's a 5. The adjacent, I can see it is 12. So I can use tan to get tan Z as the opposite of adjacent, the way you see it down there on the screen in red. Opposite of adjacent, which is 5/12. Now, why inverse trigonometric functions? Inverse trigonometric functions will now help us obtain the exact value of Z. Okay? Because now there we now just know how to get tan Z. But now the question is, how do you get the real Z? Let's go to the next slide. The next slide is coming there, slide 11. So how do you obtain the real Z? Okay, how do you obtain the real Z? And that's what we are talking about, the inverse function. The inverse function. The inverse trigonometric function. The inverse trigonometric function. So let's get back to the next slide. The next slide. The next slide. The next slide. So that's what I was saying, that to get your Z, we get the inverse of tan Z. Of tan Z is equal to that, which we denote as the. Now, to get the tan, you write tan, you can pronounce it as 10 power negative 1, brackets 5/12, and then you'll be able to get the Z. So but you don't pronounce it as tan power -1. We normally pronounce it as arctan. So you say Z equals arctan of 5/12. What you're seeing there as tan inverse, tan power -1. You don't read it as tan power -1, but arctan of 5/12. Or tan inverse of 5/12. But most importantly, I wanted you to see how, again, we can use the calculator to obtain that value. That calculator, you see it has that button shift. Just the first button, the starting button there, shift. So for instance, if I want to get tan inverse of 5/12, I say shift tan, then I press the button for tan, shift tan, then I write there that value, 5/12. So it will give me 22.6. I wish you could try that out. Shift tan, okay? Then it just that button. There is cos, sine, cos, tan. So shift tan, then to write tan power -1. Then you feed in 5/12. So it will give us 22.6. Okay, so that is those numbers there are for your practice. Sine. But I'm going to work for you the sine of theta. Sine of theta is equal to 0.5. So again, to obtain theta, we are going to get the sine inverse or the arc sine of 0.5. So I'll say shift sine 0.5. What do I get? Shift sine. Then to obtain the cos inverse, meaning for cos, I'll again say shift cos, then I feed in the value 5/13. Or you can say brackets 5 divided by 13. Same story for Roman numeral 3. Tan theta is 2. So shift tan, what do you get? That Roman numeral 4 should be sine x. Sorry, sine theta, not sine x. So sine theta is equal to 0.866. Again, you'll say shift sine, then you feed in the value 0.866. So I've written the answer there for you. The answers are down there in red, but I've disorganized them. I've not arranged them in order. So you check out the value and you check which answer is correct, then you tick until all the 4 are done. Good. So let's look at the next example. The next example is asking us to calculate a simple thing here. Let's calculate angle YX. It's Y. No, it should be YZX. YZX. Okay, no, fine. Let it be YXZ. Calculate the angle YXZ. So YXZ, angle YXZ, YXZ. How do I obtain angle YXZ? This is a 5 here, and this is a 12. So angle YXZ, this is the angle. YXZ, this is the angle. Let me call it theta. So how do I obtain theta? I know that the tan of theta, okay, by the way, I'm even rushing into tan. First of all, the hypotenuse is not there. Because the hypotenuse is not there, I should not dream of using the sine and the cosine. The hypotenuse is missing, and yet I want an angle. So I should look for a ratio, that is either sine, cosine, or tan, which has both. And you can see if this is theta, that is the side opposite. So opposite is there, the adjacent is also there. So I have to use tan is the opposite over the adjacent. And so this is the same as 12 all over 5, that is 2.4 is the tan of theta. So to get the theta, we are going to use the inverse function. So it will be shift tan. So theta is, you can pronounce this as arctan. Arctan. Say it again. Arctan or tan inverse. Oh, you have not got it. Arctan or tan inverse. So arctan, or if you like, you'll choose what you like. If you like, be calling this arctan of 2.4. So get hold of your calculator. You press the shift button. Press the shift button. I'm going to do the same story. Shift button, tan 2.4. Okay, I'm getting 67.4. 0.4 degrees. So that is my angle YXZ. And they're asking for the length Z. This was the length Z. This one I'm not going to do it. Pythagoras theorem. Okay? Pythagoras theorem. Z is squared. Oh, okay? Z squared is 5 squared plus 12 squared. Confirm that your Z will become 13. Complete that, it will become 13. Okay? Trigonometry is very, very simple. Okay? Very simple. You don't need to be scared of anything at all. So let me show you one example here. Let's write one example here, because I don't want you to say, but teacher, for you the numbers, I think for you have solved it, that's why you're doing them so easily like that. Let me guess also a number here and we struggle with it together with you. Math is a simple subject. Nobody should ever scare you about mathematics, not at all. Very simple as long as you do the practice. That's the most important thing. When you do the practice, the subject will always just be a walkover. And that's what I want to encourage you to be doing. Practice. Okay, look at this one. Example. Okay, so there we are. Find the angle marked theta in the figure below. The angle marked theta. So I come to Roman numeral 1. Where is the theta? First of all, identify where the angle is. It is here. The moment you have identified that, the next thing should be my SOHCAHTOA. Okay? My SOHCAHTOA. So, SOHCAHTOA. See, this is something you should never forget when you're dealing with trig. never forget, okay, the SOHCAHTOA. So my SOHCAHTOA, so I have my SOHCAHTOA here. If this is my theta, you see, this sometimes that normally confuses us. You know, most of you have no problem with the hypotenuse, but the problem is always now, where is the adjacent? Where is the hypotenuse? And that should never disturb you at all. The opposite, I told you yesterday, remember, we like the side facing the angle, directly facing the angle. Like I used the illustration on Monday, of someone looking at you straight in the face. That is when that person is opposite to you. But the one on the sides of your arms, that guy is adjacent to you. So I have my theta here, okay? So that is my opposite. This is the hypotenuse. And if I have the opposite and the hypotenuse, if I have the opposite and the hypotenuse, that is strictly sine theta. So I'll say sine theta is opposite over the hypotenuse, and my opposite is 7 over 12. Okay? So my theta, therefore, is now, not again tan inverse. Now the function has changed. It's now a sine function. So we shall say sine inverse or arcsine. So sine inverse, but written like this. 7 over 12. And then you get hold of your calculator. These values of sine inverse do not exist anywhere else apart from your calculator. So get hold of your calculator and say shift. So that will immediately give you the sine inverse of, that is 7 over 12, or divide by 12. I'll put it in brackets first. What do I get? 35.7. .7 degrees. So that is the value of the angle theta. Okay, that is the value of the angle theta. Now let's look at Roman numeral 2. They're asking us again to get the angle theta. To get the angle theta. And the question is, how do you obtain the theta? Again, it goes back to this SOHCAHTOA. Okay, the SOHCAHTOA. So the SOHCAHTOA, how do you obtain this? Let's check. The opposite is not there now because opposite is missing. So I should not think about using sine. I should not think about, okay, this is what I'm saying. So SOHCAHTOA, the opposite is missing. So I should not think about using sine and cosine. Let me try to think about the cosine. Is the adjacent there? Yes, the adjacent exists. Is the hypotenuse there? Yes, the hypotenuse exists. So I will then say that the cosine of theta, okay, if you can focus it so that these guys can see it better. So the cosine is equal to the adjacent over the hypotenuse, and my adjacent is 6.2. Maybe I didn't talk about this. Maybe someone's like, now where are the units? See, this is a ratio, 7 over 12. 7 over 12, the centimeters cancel. So the units are not so important if you're dealing with a ratio. They'll always cancel out. So my adjacent is 6.2. divide by 13.9. So I get hold of my calculator. I say what is 6.2 divided by that is 13.9. Oh, this is, so the cosine of theta is always give your values to 4 decimal places. 0.4460. 0.4460. So you get the cos inverse, and that becomes, let me get my cos inverse. Shift cos inverse. What do I get? The cos inverse of 0.446. Exactly. That is 63.5 degrees. That is it. So let's have the next exercise. Cast it there for my friends. Yeah, so our time is up, and you've been very good students. I want you to try out that exercise. You're going to meet again. Same topic, trigonometry, the day after tomorrow. Senior 3 class and 4 class. Tomorrow we shall be handling A-level mathematics. So thank you so much. You've been a great audience. Like I said, this show is brought to you by Code High School, Top Television, Top Radio, Christian Life Church. Please keep staying here. We shall continue giving you that information. Thank you so much.
Television, your family network. Top Radio yeyongedde okwanguyiza mu ngeri gy'oyinza okunyumirwa empeereza yaayo. Tukuleetedde app ya Top Radio ng'eyitibwa Top Radio Uganda. Ng'eno osobola okuwuliriza Top Radio ku smartphone yo buli kadde wonna w'oli. Ky'olina okukola, kozesa smartphone yo ogende mu Play Store olwo downloading app ya Top Radio eyitibwa Top Radio Uganda. Onyumirwa empeereza yaffe ku ssimu yo. Nyumirwa Top Radio. Osobola n'okutufuna ku website yaffe topradiouganda.com. Top Radio, entikko y'emiziki n'ebisensa. Life Day and Boarding Primary School ly'essomero eryazimbibwa ku musingi ogw'okutya Katonda nga tusomesa abaana okuva ku nursery okutuuka ku P7 era nga tulina ebisulo eby'omulembe. Essomero lyaffe lirina buli ekyetaagisa okuyigiriza omwana wo nga library, computer lab nga kw'otadde n'abasomesa baffe abatendeka obulungi. Tubangula abaana mu by'emizannyo era ng'enjigiriza yaffe eri ku mutindo gwa nsi yonna. Tulina clinic era nga mulimu omusawo omukugu omutendeka obulungi. Tusangibwa Bajjo kilomita 1.5 nga wakava ku Jinja Road mu Trading Center y'Ekigunga. Okuwandiisa abaana kugenda mu maaso, tukubire ku ssimu zino.
Are you looking for land with access to water, electricity and social amenities? Look no further. Zion Estates has got the biggest, most secure and well-planned estates in Uganda. We offer flexible payment terms on all our plots. So why keep renting? Find us at Zion Building 2nd floor, Chibuye, Entebbe Road, or our branches in Boise. Zion Estate, your home, your prestige.
The Ministry of Health has gone ahead to start a campaign, the Tonsemberera campaign. It means don't come near me. Keep your distance. And the distance we are talking about is 4 meters. You don't know whom you are meeting. You don't know where your best friend has been. You don't know who in your community traveled. You don't know when they came back. Science is already telling us that 50% of people infected with COVID-19 may not have any signs and symptoms at all. So please maintain the Tonsemberera campaign.